Hi, this is Chamon, and I'm about to present the Project 1 for System Architecture course with a proposal of improvement for Ford's infotainment system architecture. First, let us start by defining what infotainment is. Infotainment is a system that commits to deliver information and entertainment to the user. On the vehicle level, these functions are essentially delivered by the radio and by the connectivity module. In an entry series vehicle, the current infotainment system is composed by the subsystems presented on the block definition diagram on the screen. So here we have sync, which is the connectivity module. We have the audio head unit, which is the radio, the antennas, the speakers, the electronic finish panel, which is the controls, and the display. Although a lot of other controls are also performed by the display, the touchscreen display. But here you're going to focus on the electronic finish panel, which is a separate module. It's interfacing with a lot of other components, as you're going to see in the next slides. So most of the modules are interconnected, providing data to each other in order to execute their functions. For example, the user makes the selection of the volume level he or she wants to listen by rotating the knob on the AFP, which translates this action into a CAN message containing information of how many steps higher or lower the user is changing. The message is hence received by the AHU, which increases or decreases the volume and informs the sync through CAN what volume step is being set. The sync works as a gateway to the display, which is not connected on CAN, as I told you, that will show the HMI with the volume level being changed on the screen. Here you can see the updated architecture, which consists in the incorporation of 3 of the subsystems into an integrated sync unit, capable to deliver same or better functionality with optimized hardware and mechanicals. For example, sync already has a very powerful and subsidized DSP, much more powerful than the DSP that is used by the radio now. So the radio DSP can be deleted and all its functions can be executed and performed by the current sync DSP. So it's a big saving on hardware just by saving the DSP, for example. That will result in a much cleaner and architectured interface, as can be observed in the internal block diagram on the screen. Now the system does not require as many ports and interfaces as it used to, making the architecture simpler and more effective. The proposed infotainment architecture is based on the following expected outcomes. This will represent a very significant cost saving and also very strong effectiveness improvement of the system and its development. So basically, we're expecting to reduce the supply base, first of all, because since each of these 3 subsystems has at least 2 suppliers to support the multiple programs of Ford, reducing from 3 to 1 single component, the number of suppliers will be reduced from 6 to 3, which means half of the commercial efforts. It also represents a great saving on engineering efforts, since the engineers would not have to deal with so many suppliers and either make sure all of them meet the deliverables and all of them meet the deadlines for the program. So it's much simpler, much more effective timing for the engineer. We're also counting that this is going to reduce the interface specs. Since all the 3 systems, the 3 subsystems would become a single one, the boundary interfaces would be reduced. For example, we don't have to define anymore how the STARS, which is the satellite radio interface, has to be between the AHU and the sync anymore, because they now into the same component, the same module, so they communicate with each other internally, so that we don't need to specify how the signal has to work. Same for the audio signals that have to go from sync to the AHU, for example, and etc. We're also counting on the focused core engineering and also that the application engineering will be reduced considerably because the core have a much more efficient development time. Considering this change, it's now every one of the core team focused on writing the specs for a single component. But from the application standpoint, which is here the biggest saving on this topic, we're expecting a big reduce of the headcount because right now we only need one engineer to perform all application of this component to each program, and previously we had at least 3 engineers doing the application of those 3 components. There's also an opportunity to have savings on because we have unique chassis, unique hardware, and unique brackets. So there's also that would represent savings on the piece cost and the weight. Obviously, we're gonna have a lot of weight reductions and a lot of savings on engineering effort and commercial effort as well. So it's very possible that we're going to have a much better and effective design with the proposed infotainment architecture. So this study proposes a very consistent idea, some very consistent ideas that will, if implemented, will certainly ensure a big amount of savings to the system overall. Not only cost savings, but also time savings and effort savings. However, it requires further technical analysis and deeper investigation of the financial business case in order to guarantee that the implementation of the new architecture can fulfill what it is proposing without compromising anything on the system. Thank you.